The question says that two wires are made up of same material and have the same volume. The first wire has cross-sectional area A and the second wire has cross-sectional area 3A. So if the length of first wire is increased by delta L, it's saying that the first wire length has been increased by delta L. So on applying a force F, how much force is needed to stretch the second wire by the same amount? So how much force is required to stretch the second wire by the same amount? Now let's draw a rough figure like if we have first wire, length is L and area is A. Second we have 3A and it would be L by 3. Now we'll be applying a Young modulus is same for both the wires. So basically, so for wire 1, Y is Young's modulus, so it is basically F by A upon delta L by L. And for wire 2, F dash upon 3A delta L upon L by 3. This is equation number 1. Equation number 2, we'll divide both the equations. Now we'll be dividing both the equations. So we'll get, if we'll divide, 1 is equals to FL A into delta L, F dash into L, that is 9 into delta L into A. So that will give you F dash by 9 is equals to F. So F dash is equals to 9F. So 9F force should be applied so as to stretch the second wire by the same amount.